Let us look at this data now that Manning and Hartley collected by doing what I was not able to do, that is picturing several, I think there were 19 that they cited in their paper, peacocks while they were facing them. So they counted the number of ocelli, then computed the train symmetry, and here you can see as the number of ocelli increases, the train symmetry decreases. And if symmetry is a criteria for the beauty of a display, then lower this score is, the score of train symmetry, better it will look. Just like golf scores, lower is going to place you higher. So by and large, you do see a negative association. Of course, it's not necessarily going to decrease consistently. And well, the peacock was making a good display, so why don't we try to make a display of our numbers as well? And a way to do that in Excel is this. Go to this part on the tool, which Excel calls Chart Wizard. Click on it. We are looking at a bivariate data in which we are making number of ocelli as the explanatory variable, and train symmetry is the response. So we'll click on scatter, and the selection in this order is going to plot this on the x-axis and this train symmetry on the y-axis. So here we go. Let's write our label and titles. So here let's just write peacock's tail, okay, and then here is the number of ocelli, excuse me, and here is the train symmetry, okay, and then we go to next. I think we are ready to finish it. We can remove some unnecessary portion by clicking on them and deleting it, and let's enlarge the picture so that we can see it better here, and we will enlarge in this direction also. Okay, now our x values are way out of bounds, so we can adjust that. Notice this, just bring your cursor at the x-axis, double click on it. You want to adjust a scale, so just click on a scale, and we don't want to make it fit too tightly, so we can start at 100. Yeah, that's pretty nice. Now you see this, that there is a negative association, right? And it will be nice if we could see a mathematical equation that can give us some idea of this negative association. So to do that, and here we are going to go with linear relationship, the way the graph looks. Let's click on the graph, so we will get a chart option here. Now notice this, if you don't click on this graph, there is no chart option here. So click on it, get to your chart option, and what we want to do, we want to add trend line, right? So let's click on that here. Linear is the one that we want, and well, in this picture you see that for a positive association, but it will adjust according to ours. Click on the options, and we will go ahead and let it display everything that it wants to display for us, because it doesn't cost us to use this, okay? And so here we go. So this is equation of line showing the negative slope, that this is the line, that is the line of best fit for this data, okay? And remember, this R square, if you don't remember, I'll help you review. That is, this is called the coefficient of determination. What it does is this, that notice this, all these observations, they are varying. Like if you look at the y values, it varies from point to point. Now if we walk along this straight line, we understand it very well because we know the equation. So that's helping us understand how does y vary according to the values in x. So what this does is that this gives us the proportion of the variation in the y values that is explained by the line of best fit, or in other words, about 87% of the variation in the train symmetry is explained by this line of best fit. All right, so looks like that the peahen understand this regression line very well, and I'll finish by first adjusting this anomaly. That is, our scales are going down to -5. I want to remove it because our train symmetry was defined as absolute value, and absolute value can't be negative. All right, now I have one more story to tell you about peacocks. Let's leave that as our next attraction. Okay, and if you have any questions on these, just make sure that you contact me. All right.